Hi guys, you're watching channel Mr. Electron, and this what you see is a high voltage transformer from a CRT TV. Now here in this video I'm not going to make a high voltage supply but a low voltage high current supply, which I'm basically going to use for the solar panel. Like it produces 18 volts and I'm planning on converting that 18 volts to 12 or like 13 volts and increase the current for the decrease in voltage and thus achieving maximum power utilization. Now guys, I'm going to use these two wires for the primary high current winding of the transformer with a size thickness of 0.70 mm, and I'm going to use two of these as one. So guys, this is the plastic piece on which I am going to perform the primary and secondary winding part. Well guys, the process is simple. This is the starting end of the wire and this is the end point of the wire. Okay, let's give it a turn over here as well. So the starting, the ending. Now keep them like this and then move the wire like this to find the middle of the wire. This is the middle part. Okay, so after we have found the middle part, we will give a little turn over here like this to differentiate from the rest of the wire. Okay, so it is going to be something like this. Now take the plastic piece, okay, and this is going to be the first piece that is going to fit the plastic. So let's place it in the middle, which I suppose is this one, and then from the side lock it. So this is locked over here, as you can see, and now starts the winding part. Now guys, take the first pair of wires and start turning it in the clockwise direction until the wire finishes off. One turn completes over here. So guys, here I have achieved around 14 turns. Okay, after that give a cut like this, so half of the first winding is complete. Now turn it like this and then place an insulation sheet and start your first turn. So the 14 turns for this one have also completed. Take it from here and fold it. Yeah. Okay, so the primary winding is done guys. Now comes the secondary. Now guys, with that being done, let's move on to the secondary high current winding, low voltage. So I'm going to use this wire and its size is around 0.55 mm. Okay, so the first wire that I used was 0.70 and this is 0.55, but I doubled the first wire and here I quadrupled it. So in turn the overall output current is going to be higher for this one. So let's complete the winding process. So for that I'm going to this time wound the wire on the other side. You see, this side is for the primary low current high voltage and this side is for secondary low voltage high current. Okay, so let's turn these two like this and move it in this groove and place it like this to make it steady. And done. Now comes the insulation sheet. Okay, done. And now starts our second rewinding. Now that's one turn, and in total we have to give 10 turns this time. 2, 3, 4, 5, 6, 7, 8, 9, and the last 10, and bringing it down here like this, and done. So guys, the transformer process is almost complete. Now comes our ferrite core. You see there is a little gap over here. That's a little bad news, because this is going to like reduce its efficiency by 4 or 5%. Well, I think I can do a little better. At least I can remove that unwanted motion by placing a tape at the ends. Same for this one. Done. Okay, and guys, it is also recommended to create a gap, like the two cores should not be touching each other. Okay, so this is also going to perform that function, and here we have a little more, and voila, the gap is created. Now it is not a complete joint. Okay, yeah, quite stiff this is. Done. Now comes this, and done. Looks beautiful, doesn't it?
Guys, in my previous video, I asked you a question which none of you could give a correct answer. The question was, how could we reduce the magnetic locking in a DC motor? So here I'm going to answer you the question. So that is by making a skew rotor. That is going to reduce the magnetic locking between the rotor poles and the stator poles. Technique is usually used in servo motors. This is a servo motor that I am opening in front of you, and you will see a skewed rotor inside. The question for this video is what is a servo motor? Again, what is a servo motor?